Black holes are invisible to the human eye. Don't be fooled by their seemingly small appearance. Even the most massive stars nearby can be mercilessly devoured by them. When an object approaches a black hole, tidal forces stretch it into a long, thin shape, like spaghetti. It then spins rapidly within the accretion disk, before gradually falling into the black hole's interior, until nothing remains. So why can black holes swallow everything? And how incredibly strange is their formation process? According to Einstein's theory of general relativity, gravity is the result of massive objects curving the fabric of spacetime. When a celestial body is sufficiently dense and massive, spacetime becomes extremely warped. This is what we call a black hole. The gravitational pull of a black hole is so strong that not even light can escape it. That's why black holes are invisible. However, astronomers can still detect them by observing celestial objects orbiting what appears to be nothing, or by identifying the accretion disks formed when black holes consume matter. It's commonly known that stars like our sun have enormous mass. In theory, they should collapse inward under their own gravity. But while the sun undergoes nuclear fusion, it generates an outward pressure that balances the inward gravitational force, allowing it to shine steadily with light and heat. However, when a massive star reaches the end of its life and exhausts its nuclear fuel, this balance is broken. The core collapses, triggering a supernova explosion in the outer layers. If the core is massive enough, it continues collapsing into a stellar mass black hole. Our sun, being a relatively small yellow dwarf, won't become a black hole. Based on calculations, a star needs to be about 20 times the mass of the sun to eventually form a black hole. Once a black hole is formed, it becomes a monster that devours everything. In the early universe, when celestial objects were abundant, black holes swallowed nearby stars, planets, interstellar dust, and even other smaller black holes. Through this process, they grew increasingly massive, eventually becoming supermassive black holes. For example, in April 2019, the Event Horizon Telescope captured an image of the supermassive black hole at the center of galaxy M87, which has a mass 6.5 billion times that of our sun. In the image, the black hole itself can't be seen directly. The brilliant ring around it is actually light emitted by superheated matter being pulled inward. The boundary of a black hole is called the event horizon. Once anything, including light, crosses this boundary, it can never escape, in theory. That's why no one can say for certain what lies inside a black hole. But just imagine, if humans could somehow enter a black hole, what would we see?